So, welcome back, guys. This is Sanjay. Hope you're all doing good. So, we are starting a new chapter from class 11th chemistry, that is the structure of atom, which is the most basic and very important chapter in the point of both the board exams and any competitive exam you take. Basically, you will read this chapter to some extent, in physics also in class 12. So um, the more efficient and depth you learn here, you will be so good in your class 12. I myself felt I'm basically so weak at physics, but I felt very strong. I had that confidence when I was doing this chapter in physics in class 12th. So this is basically class 11 starting, and I would like to emphasize one thing before starting the chapter. Whatever you have studied about the structure of atom in class 9, please do forget about it. Forget in the sense, for example, I would say, if you take mm, for example, they'll ask what is the configuration, electronic configuration of helium. You would say what? Two, right? of for understanding, I'll say, if you take for example lithium, hydrogen, helium, lithium, just third. Okay, so you would say what? Let's say 2 comma 1, right? So we'll fill in the order 2 comma 8 comma 8 comma 18 comma 18 comma 32. So but that won't work here, guys. So I am warning you, at the beginning only. So we'll take up slowly, no issues. You can be very calm, and please listen to the lectures. And this is a big chapter. If you see NCERT, it's around 50 pages. So when you just enter into class 11th, we take this chapter. So essentially, the first chapter is more some basic concepts of chemistry, but this chapter will be so interesting. So that I'm taking this. I'd start up this chapter. So please follow and share it to as much friends and so at first, um, which who actually introduced the idea of atom. So if we will see some history about the atom at the beginning. So if you see, always, the philosophers from Greece, basically, they would they find everything. They invent, not invent, basically they discover everything existing in science. So they very old, back days, they discovered that every matter, the matter means everything you see around is matter, basically. If whichever has mass, that is considered to be matter. I probably think whatever thing you would see around you is matter, right? So every matter is made of atoms. So that's what they thought. They had no proof or nothing, but they thought that. And the word atom was derived from the Greek word. Basically, they found it, right. Atomio means indivisible. Okay, atomio. I don't know how to pronounce atomio. So from that, the word atom was derived, basically. So these ideas were basically speculations from the Greek philosophers, and they had no proof from till 19th century. Uh, in 1808, our famous Dalton came. You have studied about him in class 9, right? Dalton's atomic theory. So we'll just revise about the Dalton's atomic theory. His name is actually John Dalton. So he formulated, some precise definitions of the atomic theory, basically. So before that, I would like to say, I will give brief introduction to what we would study in this chapter. So we take up the discovery of electron, proton, neutron, everything, basically the histories, and we slowly go into the models of the atoms, wherein we study Thomson's model and Rutherford's model. These you should have studied in class 9th, right? But we'll take up 1 second here. Rutherford's model and the failures of Rutherford's model. the Thomson's model. And up to this, you should study in class 9. But after this, whatever comes, this is completely new for you people. So what happens now after the failure of Bohr's theory, sorry, Rutherford's theory, which is due to the classical electromagnetic theory of radiation. So that we'll see, don't worry. So given by Maxwell, actually Maxwell only disproved the Rutherford's model. So there what happened after that, Niels Bohr, his name is Niels Bohr, he came into picture and he gave a model. Basically, that also to some extent failed, and finally we take the quantum mechanical model of atom. So this you can keep it as at the very basics of the quantum mechanics. Basically, the all words are fancy looking words, but trust me, guys, all are simple if you understand and go into depth at the starting itself. So by the way, if you have any doubts, you can ask down in the comment section below, so that I would answer. And so we'll now take the Dalton's atomic theory. So he told he told that every matter is composed of very minute particles called atoms, that the Greek philosophers also told. He also told this point, and which can't be divided further. This is most important, but this actually false, right? Now now that electrons, protons are all subatomic particles. So this point also fails, and basically this point fails. And atoms of different elements differ from each other. Atoms combine to form elements, right? So if you take hydrogen atoms combine to form hydrogen element, that is basic, right? So atoms of different elements. So hydrogen atom, if you take hydrogen molecule, sorry, H2 molecule, if you take H2, right, hydrogen, so it consists of similar hydrogen atoms only, but many in number. But those atoms differ from the atoms of helium molecule. That's pretty obvious, right? So differ from each other in their properties and masses. In every aspect they differ. So this is to some extent correct by which Dalton's gave. So then he told atoms of different elements combine in a simple ratio. This also is correct. For example, if you take H2O, if you see by mass, it would be like 8:16 ratio. But in simple ratio, it would be 1:2, right? So that's why H2O. So 2 hydrogen atom and 1 oxygen atom. So that's why this is also a correct point only, and this is the most important point. So right, like energy is always conserved. Atoms, the masses of atoms are also conserved. That is, they can be neither created nor destroyed. So in these days, this point is also proven wrong. Wrong in the sense that it's true that the masses are conserved, but according to Einstein, you will all study in the due course of these 2 years. Einstein said that actually mass and energy are convertible. So mass can be converted to energy and vice versa. So masses are conserved, but it is transformed into the form of energy. Okay. So it does not suddenly vanish anywhere. So that's what it's trying to say, and it's true to some extent also. But Dalton failed to explain about the structure of atom, and why does atoms of this point, right? Why does atoms of different elements differ from each other? And he said that the atoms combine to form elements. Why it combines, how it combines, nothing he was able to explain. So that's when we came the discovery of electron, proton, where came into existence. So we'll now see how electrons were discovered. So okay, now actually how did scientists came into the idea that atoms could be divisible, and some particles do exist inside the atom. So in 1830s, there was a famous scientist called Michael Faraday. He was actually the discoverer of some classic electromagnetism. It will study in class 12th. So in 1830, he gave 2 famous laws which is called Faraday's laws of electrolysis. So what is basically electrolysis? You should have studied in the electrolysis of a sodium chloride solution in class 10th, I guess. Yeah, 10th. So electrolyte means the solution in which electrolysis is processed. So he gave two laws basically. You will study this also. I'm saying repeatedly that you will study in this new course. So because guys, this 2 years of preparation is so humongous basically. So in the starting, you need not worry about if you need not worry if you got some less marks in your school examination. Slowly it would pick up. It's the nature of the syllabus. It's a big jump from class 10th to class 12th. So you will slowly understand. Okay. So he told that the electrolytes basically decompose, right? For example, H2O, if you take, it decomposes. So means it splits into ions. Okay. So it decomposes goes to the electrodes. Electrode means the cathode and anode connected. So it goes and deposits there. So he told that the number of moles, right? Moles in the sense which class 90 studied, right? Moles is number of particles basically that were liberated by the decomposition of the electrolyte depended upon some certain quantity of electricity which is passed. Basically, what happens in electrolysis process? You take electrolyte solution, and this is cathode and anode. This is electrolysis, right? So when you pass electricity over here, the process happens over here, and certain gets deposited here, and certain things gets deposited here. So this is what happens in process electrolysis. This depended upon the quantity of electricity passed. So that's what he discovered when Michael Faraday discovered when he was performing this experiment. And also the weights, the masses of the compounds liberated also depended upon the quantity of electricity passed. So this is basically Faraday's laws of electrolysis. So by this we come to know that something is something is relatable with the electricity and atoms. Because why because whatever comes over here and gets deposited, it's actually what some matter, right, which consists of atoms. That was proved. So according to this, electricity also was related to this matter decomposition and deposition. So that's when scientists got the idea of relating atoms and matter. So electricity and atoms. So in basically this guy, who's that? So this is where they got idea. So what he did was he took a cathode ray tube basically. This also is studied in class 9th, right? So this is basically a small setup of sorry guys, I'm bad at drawing. So this is basically the small setup of cathode ray discharge tube. A simple setup. Okay, I forgot to draw the batteries over here. So this is high voltage battery. So basically what happened, particular gases were filled over here by some special equipments, and the pressure was manipulated, means adjusted according to the experiments. Okay, basically here vacuum pump would be there. I forgot to draw this. Some kind of vacuum pump. This would maintain the pressure level and adjust the pressure level as needed. So when what is this actually? This is the cathode ray tube. Basically, it's a glass tube, actually long glass tube, and these are the electrodes, cathode and anode. Cathode is negatively charged electrode, and anode is positively charged electrode. Remember in class 9 you should have studied. So what happened was, when the voltage was as high as 1000 volts, okay, and the pressure was as high as as low as 10 power minus 2 atmosphere. This is unit of pressure. Okay, so at this point some rays started to emerge from cathode to anode. Okay, how did they know? The experimental setup is not over yet. Actually, what happened? Okay, they coat it with ZNS coating. ZNS is what? Zinc sulfide coating. Why did they coat? Because when these rays strike at this coating, it actually basically a light kind of thing comes, because it's the nature of zinc sulfide. You can say the material is a phosphorescence. Okay, that is a technical term given to it. So why it was done so? Because to detect the presence of some rays over here. Okay, this is why zinc sulfide was coated, so as to detect the presence of some rays in the tube chamber. So some went in this way. Okay, so this is basically the experiment. Now the results are important. Results, in a sense, we also see the observations also. So this is what experiment over. Simple setup. And when electricity was passed 1000, which from battery of high voltage 1000 volts and pressure 10 power minus 2 atm, rays started to emerge from cathode to the anode side, where when it struck on the zinc sulfide coating, a brisk phosphorescence came into picture, which confirms the presence of some rays over here. How is it basically? When you put some hole in the anode part, the rays goes through that hole. So if you put a hole over here, it goes through the hole and strikes it, so that bright phosphorescence comes. So this is basically a few results regarding the experiment. As these rays emerged from cathode to anode, these were named as cathode rays. So that's the name of the experiment also, cathode ray discharge tube experiment. So this one name is cathode rays. Okay, and as I said, it is detected by phosphorescent material when bright light comes. So that is how it's detected. Now these 2 points are very important. I'll explain slightly about it. You'll learn in detail when you understand what electric field, what is magnetic field in class 12th. Okay, I'll give basic idea. It says if you take Q, any charge is termed as Q. Okay, if you take any charge Q, if it is stationary, okay, any charge means charge particle means a proton, electron, whatever. Now we know, right? Protons, electrons do exist. So if you take any charged particles, when it is stationary, remember, it's important. When it is stationary, actually it exerts a field around it. Okay, it exerts a field around it, which is termed as electric field. Okay, this as simple as that, you remember like this. Okay, field around it. And similarly, when this charge moves, okay, when stationary, electric field, and motion, magnetic field. Okay, when the charge moves, charge moving means what? Actually, basically, if a charge moves, particularly if electron moves, current flows, right? So magnetic field is created around the surroundings. Okay, so this is what electric field and magnetic field. Now you know what happens actually. This is the cathode ray tube. So we keep a positively charged plate. Okay, I'm so bad at drawing, so kindly pardon. Charged plate. Okay, so this is basically what we can say electric field, as I said in the as I said just now. So positively charged plate means it actually creates field around it. So that is the thing. And one more thing, we also keep some magnet like this. Okay, we also keep magnet so that magnetic field produces. So this is basic idea. So what happens when the charge when these rays comes, when magnetic field when in the absence of magnetic field only, these electrons deviates towards the positive charge plates. Okay, this is the first observation, deviates towards positive plate. Okay, also when electric when this is absence of this, it deviates towards the magnetic field. Okay, so this is basically something you will study in class 12 if you said before. It says that any charged particle is affected by both what's this positive charged species or negative charged species, that is essentially electric field. Okay, in the presence of electric field also any charged particle is affected, and also in the presence of magnetic field also it's affected. You see why it deviates? Because of some force, right? It's going in some straight pathway, but it deviates, means some force exists. Okay, so that's basically called Lorentz force. You will study in class 12th. So this is basically what they saw. In absence of magnetic field, it deviated towards here. In absence of electric field, it deviated towards here. So do you kind of get the idea when the magnitude is equal for both the rays travel straight, right? See, if it is going a straight pathway, same force is exerted by this side and the same force is exerted by this side. Okay, remember it's not linear. Okay, if this is an object, if you apply some force here and apply some force here, same amount of force, it will stay stationary. But this is not a linear force like this, it's kind of like this. Okay, so both these force when it is equal, this travels in straight line, right? It's pretty obvious. So this is a very very great observation seen by Faraday. So at this point, actually, they found by these properties shown by the cathode rays. Okay, these properties were similar to that of negative charged particle. So basically there can be positive charge or negative charge, right? So these properties were shown by negative charge particles, hence they term this as electrons. Okay, this is basically the discovery of electrons and whole process based on the experiment based on this. So hence and we should do some experiments to determine the charge on the particle, right? So when they did that, they experimented, they came up with the following observations, so that they gave the name electrons to it, just a nomenclature, so that doesn't matter. So now Faraday alone found it, but some contributions were also made by the famous scientist J.J. Thomson in about 1897. Okay, so I'll tell what. So basically what he said, right? The cathode ray particles deviated towards this electric field or magnetic field according to the amount, the magnitude of both, right? So he told how much it deflected. Okay, the amount of deflection basically depended upon some factors. Okay, so the amount of deviation of the particles from their path, okay, from this path in the presence of magnetic field or electric field depended upon three factors. Okay, so he told the amount of deviation depended upon three factors. Okay, which is the charge on particle. So the more the charge on the particle, the deviation is more. Okay, I'll write directly proportional. Okay, dp. Okay, mass of the particle. So it's basically inertia, right? If you have more mass, you're able to run very slowly. So similarly, mass of the particle was indirectly proportional, and the voltage of the battery. So how much of current you produce here, here, right? The voltage here. So that much the deviation also was increased. So these three factors affected the deviation. So when J.J. Thomson actually carefully studied this point, okay. Magnitude, when he kept both is equal by adjusting carefully, he concluded that um, the ratio in which the charge and the mass, okay, of this cathode ray particle remained constant. So what was basically I am saying is charge divided by mass, okay, it was always constant, no matter how much you increase both, but it should be equal, okay. So this is a line, okay. I'll study this given in NCERT also. By carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path followed. That's what I said, right? So when these magnitudes were equal, it went into straight path, okay. So in this way, he was able to determine the value of E by M using the magnitude of these two, okay, electric and magnetic field. So this he came out, he found as 1.75 into 10 power 11. Charge is coulomb, right? Mass is kg. So this is for electron, okay. He found this huge result using the experiment, okay. So this is basically the result of cathode ray experiment also. So and this is where electrons were found, and the E by M ratio were also found by J.J. Thomson, okay, by J.J. Thomson, okay. Now what happened? Another story, I'll say hear it. There was one famous scientist called Millikan, okay. He performed the famous oil drop experiment, okay. What he did was, it's not so important, but I'll say what he did. So he took oil droplets, okay, in the form of mist. Mist means some cloudy thing kind, okay. He took oil drops, and through a tiny hole, okay, he actually made it allowed it to go into some electric condenser kind of thing, okay. See, when this oil drop moved downwards, okay, the motion was basically seen by telescope, okay. So um, it magnifies the object, right? So it was able to see the motion of oil droplets using that. So whatever is happening, you should see, right? Then only you will conclude some experiment. So what happened? The rate of fall of these droplets. Rate of fall means droplets, the mass of droplets per second, you can say, or per minute, whatever it's convenient, we can take it. And that electric condenser I said, right? Using that, in that chamber, using the X-rays, okay, he basically ionized the oil droplets. So basically, some condenser he took, and inside that X-rays were passed to ionize the ionize means I'll say in the further lectures, okay. He ionized that oil drops, okay. So essentially the oil drops were charged. That's what you can conclude. So these rate of fall can be it's actually our convenience. We can make it to accelerate, we can make it to decelerate, or we can even make it to fall in a constant velocity, okay. Anything we can do, it's our convenience, because the amount of X-rays and the electric condenser is in our hand, right? We can manipulate the amount so that we can fix the amount of charge on the oil droplet, okay. On this basis, he actually studied the motion of the effect of these on the motion of the oil droplets, okay. So so by doing this, he concluded that the magnitude of electric charge on the oil droplets, okay, it was always an integral multiple of some thing, okay. This conclusion you need to know. Q, okay, is always integral multiple of some constant, okay. C is constant, n can go from 1 2 3 whatever, okay. So it can be either this C, or can be 2C 3C, anything. So by experimental evidences, he said that this C is the electric charge on electron. Okay, so this constant was found out to be 1.6 into 10 to the power minus 19 coulombs. This is a constant charge on the electron. From this experiment, he found so this beautiful experiment, right? So oil droplets were allowed to fall, and with the help of X-rays, he was able to ionize it, and with manipulation, he was able to accelerate or decelerate or can make it to move with constant velocity. Anything he can do. So with that, he found some constant charge. Always the charge was some integral multiple of this electron, the charge on electron. Okay, this charge on electron was found to be 1.6 into 10 power minus 19 coulomb. Now you realize this E is 1.6 into 10 power minus 19 coulomb. So some this 1.6 into 10 power minus 19 divided by this mass gave this 1.75 into 10 power 11. Okay, this same thing I have written, right? So from this mass was also founded. See how beautiful it is. It came out to be 9.1 into 10 power minus 31. These all values you have to remember. If you practice questions, it will automatically register in your mind. So this was basically American's oil drop experiment, wherein he found the charge on the electron using the famous oil drop experiment, and using the E by M ratio given by J.J. Thomson here, he also found the mass of the electron. These all were constant. Okay, so the charge on the electron were constant, the mass of the electron were constant. So this is very, very, very less. At times we neglect this mass also. So we'll take up more and more information in the upcoming lectures. So this was basically the invention of I not say invention, at least this discovery. So this was basically the discovery of electron. So what happened, I'll revise once again in the beginning. We took up Dalton's atomic theory, wherein he said atoms was conserved and it cannot be divided, everything said, but it all were wrong because of Faraday. Okay, Faraday came and said, no, when I performed the experiment of electrolysis, the amount of the material deposited on the electrodes depended upon a certain amount of electricity that was passed. Okay, so he said some relation must exist between atoms and electricity. So that he performed a cathode ray discharged tube experiment, where he saw 1000 volts and 10 power minus 2 atm, that much low atmosphere. When it was applied, some rays emerged from cathode to anode. How did we know? Inserted, we pierced the hole on the anode, so that it went and struck the zinc sulfide coating which was given on the inside part of the glass tube, so that a brick light glows. Okay, so that the presence of cathode rays was confirmed. And in the absence and this was done, and when electric field was applied, it deviated like that. Magnetic field was applied, deviated like this. And when they both were equal, it went straight. Okay, and so by this amount of deviation, which depended upon the charge on the electron, the mass of the not electron, the charge on the particle, the mass of the particle, and the amount of the electrical and magnetic fields. Okay, here. So all these depended upon these factors. Okay, so according from this J.J. Thomson, in some 1890s, he came to found the E by M ratio, which came out to be 1.7 10 power 11 coulomb per kg. And there were other famous scientists also. They were kept on working on the experiments. So Millikan came out and said, no, the charge on the oil droplets which I took and performed were always integral multiple of the charge on the electron. Okay, he came with some number and he told that was electron. Okay, so it was 1.6 in 10 power minus 19 coulomb, and using that here we also found mass of the electron. So this was basically the introduction to the structure of atom and Dalton's atomic theory, the discovery of electron. So please do revise and come in the next class. The next lecture we take about discovery of protons and neutrons. Is pretty much simple. So depth is required, and then we slowly move upon to the atomic models. Okay, so we'll take up next time. And one more point I forgot to say. This is very, very important, guys. Okay, the characteristics of cathode rays did not depend upon the material of electrode. Whatever electrode we take, it can be made of copper or whatever. Okay, zinc, and also the nature of gas inside the cathode ray tube. Okay, it did not depend on anything. So this was very very crucial result, and some other properties which is which you can just know it. So these charge particle, okay, they also rotated paddle kind of paddle means this fan kind of thing, okay, that's attached to a stick. Okay, we used to play in childhood days, right? We'll go we will hold that, and we go to outer space so that air comes and rotates the paddle. Okay, we should have played it in your childhood days. So it also rotated a paddle, which suggested that the cathode rays also had some mass. So we came up with the mass, right? This mass, okay, 9.1 minus 12 kg. So it also suggested that, and X-rays were also produced when the rays were made to fall on metals like tungsten, copper, and these are the basic experimental results which came up when J.J. Thomson and Michael Faraday did the cathode ray experiment, which is a very very famous experiment which led to the disc of electron. So that's all for today, guys. So please revise and read the insert also if you want. Not if you want, you should read it compulsory. So if you have any doubt, you can ask in the comment section. So this is about, guys. We'll see you up in the next lecture. Thank you, guys. And if you know anybody suffering from the topic by not understanding, so you can share it with them also. So thank you, guys. Bye bye.